Okay, this is lesson 2.1, define an average instantaneous rates of change at a point for AP Cal. In this lesson, we're going to determine average rates of change using difference quotients, and we're going to represent the derivative of a function as the limit of a difference quotient. So we'll start by talking about what average change rates of change on a closed interval are. We're going to look at some functions graphically. We'll call that the function f of x. Let's say that's a, and let's say that's b. There's a point there and a point there, where the y value for that would be f of a, and the y value for that would be f of b. The average rate of change, we talk about that. We're talking about the change in the dependent variable with respect to the change in the independent variable. This is known as the slope of a line. When we're working linear equations, we've talked about the slope of a line as the average rate of change in a linear function, but it's also the average rate of change on a closed interval. If you have 2 points, you know the 2 points at the ends of your closed interval, then you can define the average rate of change on that time interval, or on that interval, sorry, if it doesn't have to be time. Let's say from A to B, the average rate of change is, in a linear function, we define it as the slope of the line is y2 minus y1 over x2 minus x1. That was the change in y's over the change in x's. Well, for the average rate of change on a closed interval, it's the same idea. Here, you have the point A, f of A, and you have the point B, f of B. And we're looking for the average rate of change. That doesn't have to be a line. That function didn't intend to be almost linear, but the average rate of change between those 2 points is the slope of the line that connects those 2 points. So that we could find the average rate of change on the interval from A to B closed interval from A to B is equal to f of B minus f of A over B minus A. Just take the y value of one endpoint minus the y value of the second endpoint, and then over the x value of the first endpoint minus the x value of the second endpoint. They have to line up. This has to be the x and y value of the same point. This has to be the x and y value of the same point. But that's going to give you the average rate of change. It's just about as simple as we can say. When we look at a table, we're given a function to select values of a function in a table. We can find the average rate of change on the interval where the endpoints are the x values that we give in a table. So we could find the average rate of change, and we'll just select ARC. Let's say on the interval from 1 to 5. Well, we're given a point at 1 and a point at 5. And so that's going to be the y value at 5 minus the y value at 1 over the x value 5 minus the x value 1. So in this case, it's going to be 15 over 4. Let's make a better 4. If you wanted the average rate of change on the interval from 1 to 3, that would be the y value at 3 minus the x value, or minus the y value at 1 over 3 minus 1, which would give you 8 over 2 or 4. That's how you find the average rate of change when you're given a table. Sorry, wasn't expecting that. Let's say you're given a function. We're going to do this analytically, and we want to find the average rate of change on the interval Sorry for the group text. -2 to 5. Then we need to find the points where x is -2 and x is 5 for that function. And in this case, we're going to look at f of -2, 3 times -2 squared minus 2 times -2 plus 1, and f of 5, and that's going to be 3 times 5 squared minus 2 times 5 plus 1. Here we have 3 times 4 is 12, plus 4 is 16, plus 1 is 17. And here we have 3 times 25 is 75, minus 10 is 65, plus 1 is 66. And so here the average rate of change would be, well, let's just do it up here, 66 minus 17 over 5 minus -2, which would be 49 over 7, which is 7. And that's how you do average rates of change on a closed interval when you're given functions analytically, numerically as a table, or graphically. That's how you find average rate of change.